Hey, my name is Surinder Raj, and I'm in Physics 2, and this is my video upload for the public lecture. The public lecture that I went to was called Will Evolution and Information Theory Provide the Fundamentals of Physics? And um, it was done by Professor Sylvester James Gates, Jr. from Brown University. He's a professor at Brown. And a little bit about his background was he was awarded the National Medal of Science from President Obama in 2013, and his work produced first introductions of concepts in physics, including the complete extension of Einstein's geometrical concepts to the theory of supergravity, genuine four-dimensional string theory based on standard model concepts, and maximal SU-SY Chern-Simons theories. He also co-authored a book called Superspace and another one, or Superspace or 1001 Lessons in Supersymmetry, and is the first published comprehensive book on supersymmetry. The reason I was really interested in this public lecture was because as being an industrial engineer, I am using a lot of math and big data sets and numbers to make sense out of data and understand why certain things happen. And I thought that this was an interesting um, public lecture because information theory is just how numbers and different data it can be communicated, presented in different ways. So I thought that combined with evolution was a cool way to see what the fundamentals of physics even was. So some cool things that I learned from this public lecture was a whole lot more about information theory that I hadn't even known. So a definition of information theory is that it studies the quantification, storage, and communication of information. Some applications of fundamental topics of information theory include lossless data compression, which are basically zip files, lossy data compression, so MP3s and JPEGs, and channel coding for digital subscriber line, DSL in short. Its impact has been crucial to the success of Voyager missions to deep space, the invention of the compact disc, the feasibility of mobile phones, and the development of the internet, the study of linguistics and of human perception, the understanding of black holes, and a bunch of other different fields. So this was really interesting to me. I thought, okay, information theory can have its application to so many different things in the world, and a key measure in information theory is actually entropy. And entropy is the amount of uncertainty involved in the value of a random variable or the outcome of a random process. And we learn a lot about that in industrial engineering as well. So it goes hand in hand because, say, if you identify the outcome of a fair coin flip, it provides less information than specifying the outcome from a roll of a die. And so some other important measures in information theory that I learned from this topic are mutual information, channel capacity, error exponents, and relative entropy. Another big concept that I learned in this lecture is supersymmetry. So supersymmetry, also SUSY, which I had alluded to earlier, is a theory that proposes a relationship between two bases of classes of elementary particles, bosons, which have an integer value spin, and fermions, which have a half-integer spin. And a type of space-time symmetry, or supersymmetry, is a possible candidate for undiscovered particle physics. So basically, Professor James Gates talked about how a lot of parts of the information theory put together with supersymmetry and how these different particles are created, and how he went to his lab and experimented with these particles and found that there is actually another set of quantum particles in that subset can provide a basic reason why physics exists how it is and how the world is through different forces and gravity and how the world works. So I really enjoyed this public lecture by Dr. Gates. I thought it was really interesting because this man is super qualified or super accomplished and has been recognized by the top, the President of the United States and other big entities in physics in this world. So this was really interesting, and it was cool to see how much data and the understanding of simple evolution, how we came to be, was basically able to provide a reason for why the physics equations are what they are and what the fundamental laws are and what they exactly mean. So I hope you enjoyed this. Thank you very much, and have a great day.